You. Good morning, dear students. How are you? I hope all of you are fit and fine and working your study properly. In previous lecture, we have discussed the properties of inverse trigonometric function and some problem from exercise 2.2 based on the properties of inverse trigonometric function. Now, in this lecture, we will discuss some miscellaneous problem of inverse trigonometric function from miscellaneous exercise on chapter 2 from the textbook NCERT textbook of your class. So let us see the first problem. We have to find the value of cos inverse cos 13 pi upon 6. Since no value is specified in the question, so we have to take the principal value. Now see the 13 pi upon 6. For inverse of the cosine function, the principal value branch is 0 to pi. Means we have to give the answer in this range 0 to pi, but 13 pi upon 6 is out of this range. So how can we solve this problem? This problem is solved in such a way. See, to 13 pi upon 6 can be rewritten as 2 pi plus pi upon 6, because when we add 2 pi and pi upon 6 we will get 13 pi upon 6. Cos 2 pi plus pi upon 6, cos 2 pi plus theta is equal to cos theta. So it is equal to cos pi upon 6. Now we have cos inverse cos pi upon 6. So by the properties of inverse trigonometric function, your answer will be pi by 6, and pi by 6 is in the principal value range. Now see the next problem. Problem number 2 is tan inverse tan 7 pi upon 6. For inverse of the tangent function, the principal value branch is minus pi by 2 to pi by 2. मीन्स हमें बेटा जो वैल्यू लेनी है वो माइनस 90 डिग्री से प्लस 90 डिग्री के बीच की लेनी है. ओके, नाउ tan 7 pi upon 6 है. tan 7 pi upon 6 it can be rewritten as tan pi plus pi upon 6, and tan pi plus theta is equal to what? Tan theta. So it is equal to tan pi upon 6, right? Now using the property of invertible functions, tan inverse tan pi upon 6 is equal to what? Pi upon 6. Now see the next problem. We have to prove that 2 sine inverse 3 upon 5 tan is equal to tan inverse 24 upon 7. For proving this, let us take LHS 2 sine inverse 3 upon 5. Dear students, we have a property 2 sine inverse x is equal to sine inverse 2x upon under root 1 minus x square, right? Okay, simply put the value of x. What is the value of x? The value of x is 3 upon 5, and apply this property. Sine inverse 2 into 3 upon 5 square root of 1 minus 9 upon 25. You will get sine inverse 24 upon 25. Now we have to change this sine inverse into tan inverse. For changing sine inverse into tan inverse, let us take sine inverse 24 upon 25 is equal to x. So sine x equal to 24 upon 25. We all know that sine is equal to perpendicular upon hypotenuse. So let us make a right angle triangle whose perpendicular is 24 and hypotenuse is 25. By the use of Pythagoras theorem, we can calculate its base. Its base will be equal to 7. Okay. Now from this right angle triangle, the value of tan x is the base upon, perpendicular upon base to 24 upon 7. So x is equal to tan inverse 24 upon 7, and see, x is also equal to this sine inverse 24 upon 25. This means that we have two values of x. So sine inverse 24 upon 25 is equal to tan inverse 24 upon 27, and this is your required answer. Now let us see the next problem. Problem number 4. Sine inverse 8 upon 17 plus sine inverse 3 upon 5 tan inverse 77 upon 36. These type of problem can be solved in two ways. Let us see the first method to solve this problem. This is the formula for sine inverse x plus sine inverse y. The formula is sine inverse x under root 1 minus y square y under root 1 minus x square. Simply substitute the value of x and y. The value of x is 8 upon 17 and value of y is 3 upon 5, and calculate it. You will get the answer sine inverse 77 upon 85, but you have to give the answer in tan inverse. So change it into tan inverse by making a right angle triangle. We all know that sine is equal to perpendicular upon hypotenuse. So make a right angle triangle whose perpendicular is 77 and hypotenuse is 85, right? By the Pythagoras theorem you can calculate its base. You have to give the answer in 10. So from right angle triangle the value of 10x is 77 upon 36, means the value of x is 10 inverse 77 upon 36, right? It means that sine inverse 77 upon 85 is equal to 10 inverse 77 upon 36. But for using this method you have to learn this formula. आपको बेटा ये फॉर्मूला पता होना चाहिए. अगर आपको ये प्रॉपर्टी नहीं पता है तो आप इस मेथड को यूज नहीं कर सकते. सपोज इन एग्जामिनेशन टाइम you have forgotten this formula, आप इस फॉर्मूले को भूल चुके हो, ठीक है, आपको ये फॉर्मूला याद नहीं है. then how can we solve the problem without using any property? Okay, now let us see. For this, let us suppose that sine inverse 8 upon 17 is equal to x, sine inverse 3 upon 5 is equal to y. So your LHS after this supposition becomes x plus y, means we will use the formula of sine x plus y. Okay, the formula of sin x plus y is sin x cos y cos x sin y. So simply find the value of cos x and cos y. Now apply the formula sin x plus y and calculate its value, 77 upon 85. So x plus y is sin inverse 77 upon 85 and the value of x is what? Value of x is sin inverse 8 upon 17 and value of y is sin inverse 3 upon 5. Simply substitute these values, sin inverse 8 upon 17 plus sin inverse 3 upon 5, 10 inverse 77 upon 36. In this way you will get the answer. Now see the next problem. Cos inverse 4 upon 5 plus cos inverse 63 upon 65. Again there are two methods of solving this question. Let us suppose that cos inverse 4 upon 5 is equal to x, cos inverse 12 upon 13 is equal to y. So by the property of inverse function, 4 upon 5 is equal to cos x, 12 upon 13 is equal to cos y. Because we have to apply the formula of cos x plus y, so we should find the value of sin x and sin y. So sin x is equal to under root 1 minus cos square x and sin y is equal to under root 1 minus cos square y. Simply put the value. The value of sin x is 3 upon 5 and the value of sin y is 5 upon 13. Now apply the formula of cos x plus y. You will get the value 33 upon 65. So x plus y is equal to cos inverse 33 upon 65. Now again see, the value of x is what? See, the value of x is cos inverse 4 upon 5. The value of y is cos inverse 12 upon 13. So substitute these values, you will get the answer. Cos inverse 4 upon 5 plus cos inverse 12 upon 13 is equal to cos inverse 33 upon 65. Now the second method is, you can also use this property. If you have learned this property, then you will use this property, cos inverse xy upon root 1 minus x square, square root of 1 minus y square. Simply put the value of x and y, you will get the answer. Now see the next problem. Cos inverse 12 upon 13 plus sin inverse 3 upon 5. Same as problem number 5. Now see the next. Sin inverse 5 upon 13 plus cos inverse 3 upon 5. We have no property of sin inverse x plus cos inverse y. So let us suppose that sin inverse 5 upon 13 is equal to x. Cos inverse 3 upon 5 is equal to y. So 5 upon 13 is equal to sin x and 3 upon 5 is equal to cos y. Now find the value of cos and sin. Now apply one formula, sin x plus y. You can also use the formula cos x plus y. आप कोई सा भी एक फॉर्मूला यूज कर सकते हो, या तो आप sin x plus y का फॉर्मूला यूज करो या cos x plus y का फॉर्मूला यूज करो. You are free. Sin x into cos y plus cos x into sin y. Now calculate it. After putting the values, you will get the value 63 upon 65. So value of sin of x plus y is equal to 63 upon 65. Now again using the property of invertible functions, x plus y is equal to what? Sin inverse 63 upon 65. But we have to give the answer in tan inverse. Okay, so change it into tan inverse. How? Sin, let us suppose that sin inverse 63 upon 65 is equal to x plus y. So sin x plus y is equal to 63 upon 65. So let us take a right angle triangle whose perpendicular is 63 and hypotenuse is 65, because sine is equal to what? Perpendicular upon hypotenuse. By Pythagoras theorem, you can calculate its base. See, here I have calculated its base. Its base will be 16. Okay. Now, from this right angle triangle, you can get the value of 10x. The value of 10x is 63 upon 16. 10x नहीं बेटा 10x plus y होगा. So x plus y is 10 inverse 63 upon 16. Now see the equation number 1 and equation number 2. In both equation LHS is same, so RHS must be same. Means sin inverse 63 upon 65 is equal to 10 inverse 63 upon 16. In this way you will get the answer. Now see the next problem. Problem number 8. Problem number 8 is tan inverse 1 upon 5 plus tan inverse 1 upon 7 plus tan inverse 1 upon 3 plus tan inverse 1 upon 8. In previous lecture I have told you a property. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. Simply put the value of x and y by taking two expression at a single time. So tan inverse 1 upon 5 and tan inverse 1 upon 7. Take one couple this and tan inverse 1 upon 3 1 upon 8. Using this property you will get this. Tan inverse 12 upon 34, tan inverse 11 upon 23. Again applying this property by taking x is equal to 12 upon 34 and y is equal to 11 upon 23. You will get the answer tan inverse 325 upon 325. But it is equal to tan inverse 1 and 1 is equal to what? 1 is equal to 10 pi by 4. Okay, so you will get the answer pi by 4. Now see the next problem. Tan inverse square root of under root x is equal to 1 upon 2 cos inverse 1 minus x 1 plus x. First of all, we will check from which side this question can be proved easily. बेटा लेफ्ट हैंड साइड आपको दी हुई है tan inverse under root x. इसको अब इससे ज़्यादा सॉर्ट आउट कर नहीं सकते. Means you have to prove this question from right hand side. 1 upon 2 cos inverse 1 minus x upon 1 plus x. राइट हैंड साइड को कैसे सॉल्व करें? By substituting x is equal to something, you can solve right hand side. Okay, but what value should be substituted? See, we have to give the answer in 10, right? We have to give the answer in tan inverse. Means you have to put the value of x in terms of 10. क्योंकि बेटा आपको आंसर tan inverse में लाना है, इसलिए आपको x के प्लेस पर जो भी वैल्यू सब्स्टिट्यूट करनी है वो 10 की टर्म्स में सब्स्टिट्यूट करनी है. Now again see the next thing. Here is square root of x and here is x, which is the square of square root of x. Means बेटा लेफ्ट साइड में जो वेरिएबल है उसका स्क्वायर राइट साइड में प्रेजेंट है. Means you have to put the value in terms of square. आपके पास दो चीज़ें आ गई. एक तो आपको x को 10 की टर्म्स में सब्स्टिट्यूट करना है, दूसरा स्क्वायर की टर्म्स में सब्स्टिट्यूट करना है. सो पुट x is equal to 10 square theta. If x is equal to 10 square theta, now taking square root of both sides, square root of x is equal to 10 theta, so theta is equal to 10 inverse under root x. Okay, now see, x is equal to 10 square theta, 1 minus 10 square theta upon 1 plus 10 square theta. Now change 10 square theta in terms of sin theta and cos theta. You will get sin square theta upon cos square theta, sin square theta plus cos square theta. Simply simplify it, you will get cos 2 theta. Okay, now cos inverse and cos, using the property of inverse function, it becomes an identity. So it is equal to 2 theta. 2 is cancelled out by 2. Your answer is theta. But you have to give the answer in that variable in which question is given. So the value of theta is what? The value of theta is tan inverse under root x. Okay. So your answer will be tan inverse square root of x. Now let us see the next problem. Problem number 10. Problem number 10 is cot inverse square root of 1 plus sin x plus square root of 1 minus sin x square root of 1 plus sin x minus square root of 1 minus sin x, it is equal to x upon 2. How can we solve this problem? See, 1 plus sin x, मैंने बेटा दोनों साइन एक साथ लिए हुए हैं, प्लस बी और माइनस बी. 1 can be written as cos square x by 2 sin square x by 2. cos square theta plus sin square theta is equal to 1 प्लस माइनस दोनों एक साथ ले लिया मैंने. साइन 2 थीटा का फॉर्मूला यूज करो बेटा 2 sin थीटा cos थीटा. हियर द वैल्यू ऑफ थीटा इज x by 2. Okay, now a square plus b square plus 2ab, so it is equal to a plus b का whole square, means square root of 1 plus minus sin x is equal to cos x by 2 plus minus sin x by 2, where when we have positive sign, then here is also positive sign, when we have negative sign, then we will get negative sign. So simply put the values cos x by 2 plus sin x by 2 plus cos x by 2 minus sin x by 2 and simplify this problem. You will get cos x by 2 upon sin x by 2, it is equal to cot x by 2. Now using the properties of inverse function, you will get the required result, it is equal to x by 2. Now see the next problem. Tan inverse square root of 1 plus x, 1 minus x, 1 plus x, 1 minus x. See, how can we solve this problem? I have told you, when we are dealing with positive and negative sign simultaneously, जब बेटा प्लस माइनस साइन एक साथ आए, सिमेट्रिकल आए, तो हम हमेशा x की टर्म्स पे साइन cos थीटा सब्स्टिट्यूट करते हैं. ओके, सो सिंपली put x is equal to cos theta. Now when x is equal to cos theta, then theta is equal to what? Theta is equal to cos inverse x. Okay, so 1 plus cos theta, 1 minus cos theta, 1 plus cos theta, 1 minus cos theta. What is the benefit of putting cos theta in the question? Because we have many formula for cos theta. Cos theta is equal to 1 minus 2 sin square theta by 2 and 2 cos square theta minus 2 cos square theta by 2 minus 1. These formulae are used फॉर कैंसिलिंग द वन. ओके, इन फॉर्मूलों को हम वन को कैंसिल आउट करने के लिए यूज करते हैं. ओके, सो सिंपली यूजिंग द सुटेबल फॉर्मूला सो दैट वन कैन बी कैंसिल्ड आउट एट डिफरेंट प्लेसेस, राइट? यू विल गेट दिस cos theta by 2 minus sin theta by 2 cos theta by 2 plus sin theta by 2. Now take cos theta by 2 common out. You can ask one question here, cos theta by 2 does not appear, then how can we take it common out? सिंपली मल्टीप्लाइंग एंड डिवाइडिंग cos थीटा बाई 2. तो बेटा जिस cos थीटा बाई 2 से आप मल्टीप्लाई करोगे वो कॉमन आ जाएगा और डिनोमिनेटर वाला cos थीटा बाई 2 आपके पास रह जाएगा. ओके, नाउ सो सिंपली टेक कॉमन आउट cos थीटा बाई 2 फ्रॉम न्यूमरेटर एंड डिनोमिनेटर विच विल बी कैंसिल्ड आउट. So you will get 1 minus tan theta by 2, 1 plus tan theta by 2. Now in place of 1 we can also write tan pi by 4, because the value of tan pi by 4 is what? The value of tan pi by 4 is 1. 1 minus tan theta by 2, 1 plus tan theta by 2 can also be written in this manner. Why I have written this thing into this? Because this is the formula, tan A minus tan B upon 1 plus tan A into tan B. Here the value of A is pi by 4, the value of B is theta by 2. So this is equal to tan pi by 4 minus theta by 2. Tan inverse and tan, after the composition becomes an identity function, your answer looks like this, pi by 4 minus theta by 2. But you have to answer the question in that variable in which question is given. Okay, so find the value of theta. The value of theta is what? Cos inverse x. Okay, so your answer will be pi by 4 minus half cos inverse x. In this way you have got the result. Now see the next problem. Problem number 12. What is problem number 12? 9 pi by 8 minus 9 upon 4 sin inverse 1 by 3, right? So simply take 9 by 4 common. You have pi by 2 and minus sin inverse 1 by 3 in bracket. You have already studied a property, pi by 2 minus sin inverse x is equal to cos inverse x. So pi by 2 minus sin inverse 1 by 3 is equal to cos inverse 1 by 3. But you have to give the answer in sin inverse. Okay, so simply change this cos inverse by in sin inverse by using this property. Cos inverse x is equal to sin inverse under root 1 minus x square. Here the value of x is 1 by 3. So using this property you will get the answer. Now see the next problem, problem number 13. Solve the following equation. What is the meaning of solve the following equation? 2 tan inverse cos x is equal to tan inverse 2 cosec x. Means we have to find the value of x which satisfies this equation. किसी भी इक्वेशन को सॉल्व करने का मतलब बेटा यही होता है कि आपको उस इक्वेशन में जो अननोन वेरिएबल है उसकी वैल्यू फाइंड करनी है. ओके, सो वी हैव टू फाइंड द वैल्यू ऑफ x which satisfies the given equation. 2 tan inverse cos x is equal to tan inverse 2 cosec x. First of all, trying to remove this number 2. How can we remove? Using the property 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. Here in place of x we have cos x. Okay, so using this property tan inverse 2x होता था बेटा यहाँ पे, तो आपने अब क्या किया 2 cos x upon 1 minus cos square x is equal to tan inverse cosec x. Cosec x can be written as 1 upon sin x. Okay, so tan inverse and tan inverse, so comparing both sides, 2 cos x upon sin square x, 2 upon sin x. Tan inverse is an injective function, right, in the principal value branch. Okay, so if we consider principal value branch, then the images under tan inverse are same if the points must be same. You have studied if fx is equal to fy and f is injective, then x is equal to y. We are using this property here, right? tan inverse बेटा tan से कैंसिल नहीं हुआ है, इस बात को ध्यान रखना. tan inverse is an injective function in the principal value branch. I am again repeating, in principal value branch में इंजेक्टिव है, सारी जगह इंजेक्टिव नहीं होता, ठीक है. तो इन प्रिंसिपल वैल्यू ब्रांच यू कैन यूज दिस 2 cos x upon sin square x 2 upon sin x. Simply simplify it, you will get cos x is equal to sin x. Cos x is equal to sin x. The principal value branch for tan inverse is minus pi by 2 to pi by 2. अब बेटा माइनस 90 से प्लस 90 के बीच में x की किस वैल्यू के लिए cos और sin की वैल्यू बराबर होती है? 45 के लिए, means your answer is x is equal to pi upon 4. Now see the next problem. In 14th question, we have to find the value of x, right? So let us see. Tan inverse 1 minus x upon 1 plus x half tan inverse x. Put the value x is equal to tan theta. So the value of theta is tan inverse x. 1 minus tan theta, 1 plus tan theta. This expression can be rewritten as in this form. Tan pi by 4 minus tan theta, 1 minus tan pi by 4 into tan theta, because the value of tan pi by 4 is 1. In the right hand side, half tan inverse tan theta. Using the composition of inverse functions, it is equal to 1 upon 2 theta. This is the formula. Tan a minus tan b upon 1 plus tan a into tan b. The value of a is pi by 4, the value of b is theta. It is equal to tan pi by 4 minus theta. Again, pi by 4 minus theta is equal to 1 by 2 theta. Simply find the value of theta. The value of theta is pi by 6. And theta is equal to what? Theta is equal to tan inverse x. So tan inverse x is equal to pi by 6. Means x is equal to tan pi by 6. So x is equal to 1 upon under root 3. Now see the next problem. 15th question. In 15th question, we have to solve out sine of tan inverse x. It is not an equation. Just we have to simplify it. Sine of tan inverse x means we are trying to change tan inverse into sine inverse. To change tan inverse into sine inverse, let us make a right angle triangle. Tan inverse x is equal to theta, so x is equal to tan theta. Means tan theta is equal to x upon 1. You already know that tan is equal to perpendicular upon base. So take a right angle triangle whose perpendicular is x, base is 1, then by Pythagoras theorem its hypotenuse is x square plus 1. Now from this triangle you can find the value of sin theta. Sin theta is what? Perpendicular upon hypotenuse. So sin theta is equal to x upon and square root of x square plus 1. So theta is equal to sine inverse x upon under root x square plus 1. This is the value of theta and this is also the value of theta. Means tan inverse x is equal to sine inverse x upon under root x square plus 1. So simply put this value. Now using the property of inverse function, you will get the answer x upon under root x square plus 1. Means right option is what? Right option is D. This option is the right option. Now let us see the next problem. Sine inverse 1 minus x minus 2 sine inverse x is equal to pi by 2. We have to find the value of x. So let us see. Take sine inverse 1 minus x into right side. Pi by 2 minus sine inverse x is equal to cos inverse x. Here we have 1 minus x in place of x. ये ध्यान रखना बेटा. Okay. Now let us take sine inverse x is equal to theta, means x is equal to sine theta. Cos theta is equal to what? Under root 1 minus sine square theta, means under root 1 minus x square. So theta is equal to cos inverse under root 1 minus x square, means sine inverse x is equal to cos inverse under root 1 minus x square. Now from equation 1 and 2, simply put the value of sine inverse x in terms of cos inverse x in the equation 1. You will get minus 2 cos inverse under root 1 minus x square is equal to cos inverse 1 minus x. Now again let us put x is equal to sine y. 2 cos inverse under root 1 minus sine square y is equal to cos inverse 1 minus sine y. 1 minus sine square y is what? Cos square y. स्क्वायर रूट भी पहले से है, मतलब cos बाई हो गया आपके पास, मीन्स माइनस 2y इज इक्वल टू cos इनवर्स 1 माइनस साइन बाई. अब बेटा जब आप cos इनवर्स इसके इक्वल है, मीन्स cos 2y किसके इक्वल होगा? यूजिंग द प्रॉपर्टी ऑफ इनवर्स फंक्शन, इफ f इनवर्स बाई इज इक्वल टू x, देन fx इज इक्वल टू y. सो cos ऑफ माइनस 2y इज इक्वल टू 1 माइनस साइन बाई. But we already know that cos of minus theta is equal to cos theta, right? So now use the formula of cos 2 theta, 1 minus 2 sin square theta, right? So 1 is cancelled out by 1, you will get 2 sin square y minus sin y is equal to 0. Take sin y common out, 2 sin y minus 1 is equal to 0. You will get the two values of sin y, 0 and 1 by 2. Means the value of y is 0 or pi by 6. But we have to find the value of x, and x is what? X is equal to sin y, means x is equal to sin 0 or sin pi by 6. X is equal to 0 or 1 by 2, means we will have two values 0 and 1 by 2. But when we put x is equal to 1 by 2 in the given equation, the equation is not satisfied, means x is equal to 1 by 2 is not a solution. So x is equal to 0 is only solution. So right option is C. कभी भी एग्जाम में बेटा जल्दी में आपके दो आंसर आ गए 0 1 by 2 आपने टिक कर दिया, ऐसा मत करना. आप उसको पहले चेक करना क्या वो दोनों वैल्यूज इक्वेशन को सेटिस्फाई कर रहे हैं या नहीं, राइट? द वैल्यू ऑफ x 0 डज नॉट सेटिस्फाई द इक्वेशन, सो 0 इज नॉट अ सॉल्यूशन. ओनली 1 by 2, the value of x 1 by 2 does not satisfy the equation, so 1 by 2 is not a solution. So only solution is 0. Now see the next problem. Tan inverse x upon y minus tan inverse x minus y upon x plus y. How can we solve this problem? Now let us see. Tan inverse x upon y, take simply y common out. अब y को कॉमन कैसे लोगे? y आपका फर्स्ट टर्म में तो है ही नहीं, तो y को कॉमन लेने के लिए हमने क्या किया बेटा, अगर फर्स्ट टर्म में y नहीं है तो y से मल्टीप्लाई कर दो और डिवाइड कर दो. तो जिस y से मल्टीप्लाई करोगे वो आपका कॉमन आ जाएगा, और जो डिवाइड में एक y आपका रह जाएगा, राइट? नाउ सिंपली पुट x अपॉन y इज इक्वल टू tan थीटा, राइट? x अपॉन y 1 को tan पाई बाई 4 आप लिख सकते हो, मीन्स दिस, देखो ये फॉर्मूला बन गया tan a माइनस tan b 1 प्लस tan a इंटू tan b, tan a माइनस b का, ओके. सो tan थीटा माइनस पाई बाई 4, राइट? यूजिंग द प्रॉपर्टी ऑफ इनवर्स फंक्शन, tan inverse and tan together will make an identity function after the composition. So theta minus pi by 4 is left. Now put the value of theta. Theta is what? Tan inverse x upon y. So tan inverse x upon y is cancelled out by tan inverse x upon y. Your answer will be pi by 4. Means right option is C. In this way, your miscellaneous exercise is completed. Now if you have any query, any doubt regarding this exercise or regarding this chapter, you can tell me in comment section. This is the summary of your chapter. This table is very important for this chapter, so you have to learn this table, right? And another key point is that sine inverse x and sine x raised to the power minus 1, both are the different things. This is the inverse of sine function, and this is the negative power of the sine x. Sine x is a value, a number, but sine inverse is a function, okay? Sine inverse is the inverse of sine function, and sine x raised to the power minus 1 is equal to 1 upon sine x, which is equal to cosec x. The value of an inverse trigonometric function which lies in its principal value branch is called principal value of the inverse trigonometric function. Okay. For suitable values of domain we have, if y sin इनवर्स x से इक्वल है तो बेटा x sin y के इक्वल होगा. ये सेम प्रॉपर्टी है. if y is equal to f inverse x then fy is equal to x. Sin inverse, these are the functions, right? Always keep this fact in the mind. All these are the function. Sin inverse 1 upon x is equal to cosec x. Okay. Cos inverse 1 upon x is equal to sec inverse x. These are some properties. Some more properties. Tan inverse x plus cot inverse x is equal to 5/2. You have already proved all these properties. Tan inverse x plus tan inverse y. And these properties are correlated to the normal trigonometric ratios. Tan a plus b का फॉर्मूला होता है बेटा tan a plus tan b upon 1 minus tan a into tan b. सो सेम प्रॉपर्टी जब हम इनवर्स ट्रिग्नोमेट्रिक फंक्शन में यूज़ करते हैं तो वो केवल वेरिएबल पे अप्लाई होती है. x प्लस वाई अपॉन एक्स माइनस वाई. सम मोर प्रॉपर्टीज 2 tan inverse x minus tan inverse y. Okay. This is the summary of your chapter. This is a historical note and it is a very interesting note. You should read this note because this note makes a interest, or I can say enhance your interest in mathematics. So you should read these historical notes at the end of every chapter, right? Thank you very much for watching this video. Have a good day, dear children. Bye bye.